hypothetic preferences, and those are quasi-linear preferences. And these are going to look a little bit different. So if you remember our quasi-linear preferences, let's draw them out to remind ourselves kind of what they look like. But quasi, so they're partially linear. So they're linear in one of the goods and non-linear in the other. And all the indifference curves, are shifted versions. Remember, they were kind of shifted vertically. Versions of one indifference curve. Of one indifference curve. And so our utility, let's just remind ourselves exactly what these quasi-linear look like. We had some function, so v of x1 is some function of x1. This is non-linear, so it could be like the square root or something like that, plus some amount of x2. So it's linear in x2 and non-linear in x1, for example. And what our indifference curves look like would kind of be like this. Where they're kind of like vertical copies of each other, where it's linear in x2 and non-linear in x1. And so what's happening here is if the budget line is shifted out, the tangency out, and so let's say the optimal amount was from tangency that made x1 star, x2 star the optimal amount. So, let's say we have some budget constraint like this. Here's x1 star, x2 star. What happens if it shifts out? The amount of one of the goods is not going to change. We're getting the same amount of one of the goods, regardless of kind of income. So we shift it out. x2 star star, and this is the same as x1 star star, and so on and so forth. So x2 star star star. If budget line shifts out from the change they made x1 star, x2 star the optimal bundle, it would just be tangent. It would be tangent at x1 star, x2 star plus k, whatever this constant k is. So this is from some increase in income. Or this plus k is associated with the increase in income from shifting our budget constraint. And so now you can see right away the income offer and the Engel curve are going to look much different in this situation. So let's kind of erase this board and take a look at those. Increase in income, in M, or income, doesn't change. I mean, this is kind of what we just saw. It doesn't change the demand for good one, or good one. Basically, they're keeping their consumption of good one the same, and they're spending all this extra income on good two. Essentially, is what they're doing. Consumption with this new income goes entirely to good one. Oh, sorry, good two, good two. good 1 is fixed. If our budget goes up, we're spending all of that new income on good 2. That's all I'm trying to say here. Hopefully it's not too confusing. So I'm just going to draw the same graph that was kind of here before, and then we'll draw the Engel curve over here. Then we got to maybe talk about it a little bit more. All right, so here's just our kind of optimal bundle diagrams, and here's those Engel curves, income, and we're going to do X1 here. All right, so like I was saying, we have these quasi-linear indifference curves. And what that meant is our consumption of good 1 didn't change as our income went up. So I'm just going to make sure that's true. You know, obviously it's harder to draw freehand, but these should all be the same amount. So no matter what our income, we're always buying this much, where we're spending all of our new income basically on good 2. So this was like, whoops, X2 star, this was X2 star star, and this was X2 star star star, let's say. Where X1, we didn't change our consumption when our budget went up. And so what that looks like for an Engel curve is, you know, at the beginning, we're going to spend a little bit. If our income was 0, then we couldn't buy any of it. At some point, our income goes up a bit, and we're going to buy a positive amount of it. But you know, once we're at this point, X1 star, it's going to be this vertical Engel curve. So it looks a little bit different. So like I said, this is, you know, this relationship is only going to be true for certain levels of income. We need kind of positive amounts of income, so we get to this point here, and then we're just purchasing the same amount of that good regardless of our income. But you know, we've got to get out there at some point. These quasi-linear, just the first part of the appendix, we talk about this quasi-linear preferences. So again, we have some utility function that is non-linear with respect to good 1, but linear with respect to good 2. That's kind of like the example that we just saw. So if you want to think about this as a maximization problem, we want to max this utility function, Vx1 plus x2, and we get to pick out how much x1 and x2 we want, and it's subject to p1 x1 plus p2 x2 equals n, right? It's subject to a budget constraint. As we saw last chapter, in chapter 5, when we talk about choice, we can kind of recast this as an unconstrained maximization problem if we kind of redefine this budget constraint. So now x2 is a function of x1, and kind of put that into our objective function. And we just have to max with respect to x1. So that's what we're going to do here. So max, we're choosing x1, Vx1 plus, and now I'm just rearranging this budget constraint to get x2 equals something, which is what I'm going to write in here, and just plug it, and just plug it in for that. So, you know, m minus p1 x1, and then everything over p2, essentially is what the math is there. So m divided by p2 minus p1 x1 over p2. And now this is basically like an unconstrained maximization problem. So we're basically putting this this constraint directly into this objective function, just like we talked about in the appendix of chapter 5, I guess it would be, the one about choice. Well, we know how to maximize that. We just take the first order condition with respect to x1. And what we're going to get here is the derivative of v x1 star prime x1 star equals p1 over p2. Right, we're just taking the derivative of this with respect to x1, or this whole thing with respect to x1. Well, it's the derivative of this with respect to x1. there's no x1 here, then we just have p1 over p2 here, because they're constants. We're holding those constant. And so notice that the demand for good 2, for good 1, is independent of income. The demand for good 1 here just depends on this price ratio. It doesn't depend on income. And so this is why we're getting that kind of weird Engel curve there. Because how much we want of this good depends only on the price ratio. It doesn't depend on income. This might seem really weird, or maybe it's hard to kind of connect that to the real world and what kind of goods. And so I think the book has a pretty good example where they're talking about pencils as kind of good 1 here, and all other goods or income spent on all other goods as good 2. When we first get a little bit of income, we want to buy some pencils. We need some pens or pencils or whatever that good 1 is. But eventually we have enough. And once we can satisfy how many of those pens or pencils we want, we're not going to buy anymore. And if our income keeps going up, we're going to spend that on all these other goods rather than on pens or pencils. So that's the idea here. We're kind of getting some of them, but after a certain point, after our budget gets to a certain point, all we're doing is spending money on these other goods because we kind of satisfied how many of good 1 we want. But again, I'm talking about changing income and things like that, but the amount of good 1 that's demanded is independent of income. For low levels of income, as soon as we satisfy how much of that good we want, then it doesn't depend on income at all.